Lithium, the soft silver-white metal, also known as white gold. It's a key component in the products we use every day. Its physical properties make it the cornerstone of many modern applications, including cell phones, laptops, and pharmaceuticals. Today, it's a major part in the fight for a better climate, with its extensive use in solar and wind energy, but more specifically, the production of lithium-ion batteries. Lithium has become the cornerstone of a new fossil fuel-free world in the form of electric vehicles. In fact, just one Tesla Model S, for instance, uses 12 kilograms of lithium in its battery. It's said that the electric vehicle world needs to get to 2 billion vehicles to get to zero emissions by the year 2040. Which begs the question, will the world have enough lithium to supply it? Let's dive in. The first ever lithium mine was created in the Black Hills of South Dakota in the 1880s. The mine contained lithium-bearing spodumene. At the time, lithium was not the primary target of the mine. It was more valuable for its uses in ceramics and glass making rather than batteries. It wasn't until the mid-20th century that lithium began to be appreciated for its potential in battery technology. The lithium-ion battery was originally popularized by the Sony Corporation, who used it in their CCD TR1 camcorder. Today, the International Energy Agency believes that by 2025, the world will face a shortage of lithium unless sufficient investment is made to expand production. The urgency is underscored by a study from Benchmark Mineral Intelligence predicting that by 2050, the world will need to produce 20 times more lithium than today just to meet demand. According to global data, today there are around 26 primary lithium mines in operation around the world. Benchmark Mineral Intelligence estimates that the world will need almost 400 new mines extracting graphite, lithium, nickel, and cobalt in order to meet electric vehicle and energy storage battery demand by 2035. This estimate includes that 74 of these new mines will be focused on lithium, with an average annual production of 45,000 tons per mine. But how can we get there in such a short time frame? Let's take a second to examine the lithium market. In 2021, the lithium carbonate market was approximately 540,000 tons. Priced at today's spot price of around 40,000 US dollars per ton, it would put the market size for lithium carbonate at around $23 billion. That market size needs to be said with the caveat that there was a recent large price swing in lithium carbonate, which used to sell for around $7,000 per ton at the start of 2021. This $23 billion market size puts the global market for lithium carbonate right in between the overall market size of silver and zinc based on current prices. Now, let's talk sources. Lithium is relatively abundant in both land and sea, but extracting it economically is a significant challenge. As of 2022, lithium extraction hit 130,000 metric tons of pure lithium per year, a fraction of the estimated 22 million tons of global lithium reserves. Lithium is primarily procured from two major sources: hard rock and brine deposits. Hard rock lithium consists of extracting lithium from spodumene pegmatites utilizing traditional mining practices to extract the metal from ore. Globally, regions such as Australia, Canada, and Brazil are focused on this method of extraction, where lithium-bearing pegmatites are abundant. Over 60% of global lithium production comes from hard rock sources, with Australia being the globe's leading producer with over half of global lithium production in 2021. As a result of the cash flow from the lithium industry in Australia, the Aussies have a robust amount of interest in lithium stocks. Lithium brine, meanwhile, consists of saline groundwater that has been enriched with dissolved lithium. Brine deposits are dominant in the lithium triangle, which covers Chile, Bolivia, and Argentina, where lithium brine has accumulated within the vast salt flats throughout the Atacama Desert. The region has nearly 50 million tons of estimated resources and is thought to hold 54% of global lithium reserves. One key aspect that differentiates the two types of lithium sources is the time and cost to develop claims into producing mines. This is where lithium brines have a clear advantage. Hard rock deposits are often found in remote areas with little infrastructure. The exploration stage, from prospecting through advanced exploration, is estimated to cost upwards of $45 million for many deposits, with the different phases of exploration taking from 3 to 6 years. Lithium brines comparatively are found in salt flats, where access is available year-round with fewer topographical challenges. Discovery through advanced exploration can cost as little as $3 to $4 million with an experienced team, given that exploration for brines is very much like drilling a well for water, meaning equipment is abundant and the process is rather straightforward. Brines also have the upper hand when it comes to development and construction, which combined can cost anywhere from 150 to 300 million in terms of capital expenditure, while the timeline can be as little as 2 years. Hard rock sources comparatively can take up to 4 years, and costs can run into the billions. Hard rock is hard. In Canada, every lithium cycle, we are told various companies will hit production around the corner, which rarely ever happens, and when it does, it's often short-lived, largely due to the volatility of both the capital markets and the prices of lithium. The immense cost of hard rock development is evident in the bankruptcy of Nemaska Lithium, who raised and burned $1.1 billion to build out the Whabouchi mine in Quebec, despite immense amounts of government support. Let's hone in for a second on the lithium brine process. How does one take lithium that comes in the form of a watery brine and turn it into the metal that we use in our smartphones today? The most common method of lithium brine extraction begins with drilling to reach the underground brine deposits, which are then pumped to the surface and directed to evaporation ponds. In these ponds, the brine is subjected to solar evaporation, which effectively means leaving the brine out in the sun to dry out the water. This concentrates the lithium salts and other contained elements like potassium and sodium. Some operations even utilize reverse osmosis to quicken the concentration process. Once the evaporation process results in an optimal lithium concentration, the brine is sent to a lithium recovery facility where it is put through several treatments to isolate the lithium and produce a saleable form. Depending on the specific process used, the resulting product could be lithium hydroxide, lithium chloride, or most likely the most common form of lithium sold, lithium carbonate. However, there are some downsides to brine extraction. Extraction from brine reservoirs consume considerable water and energy resources. Estimates suggest that around 500,000 gallons are required to produce just 1 ton of lithium. Given that most of the lithium-rich brine deposits are located in arid regions of South America, this high water consumption exacerbates the existing water scarcity for local communities and natural ecosystems. Moreover, local communities in lithium-rich regions have been voicing environmental concerns about lithium mining from brine since the early 2000s. Particularly in arid territories like the South American salt flats, access to water is crucial for the sustenance of local communities, their livelihoods, and the indigenous flora and fauna. Yet, lithium extraction processes put this vital resource at risk. For example, the Friends of the Earth organization issued a report emphasizing that as lithium demand surges, the effects of mining are increasingly affecting communities where this harmful extraction takes place, jeopardizing their access to water. Now, of course, innovations are coming that could mitigate this challenge. The drive for more efficient and environmentally friendly extraction methods has given rise to innovations such as direct lithium extraction. Unlike traditional brine mining that requires evaporating brine in large pools to concentrate lithium, DLE involves pulling the brine directly into a processing unit. Through a series of chemical processes, lithium is separated and the remaining brine is injected back underground. This method has the potential to produce battery-grade lithium carbonate or hydroxide in a matter of hours, without the need for transportation to a separate processing facility, all while requiring much less land. This can potentially unlock resources in areas with brine containing lower lithium concentrations and more impurities, such as in abandoned oil wells in places like Alberta and Saskatchewan. With the global demand for lithium expected to skyrocket, the need for lithium has never been stronger. In fact, the market for lithium-ion batteries is expected to more than triple from $30 billion in 2017 to $100 billion by 2025. As such, anticipated lithium demand is expected to escalate from around 500,000 metric tons of lithium carbonate equivalent in 2021 to somewhere between 3 to 4 million metric tons by 2030. To meet generally expected demand forecasts, the world needs to increase global lithium supply by over 300% by the year 2030, as well as making strides in technologies like direct lithium extraction. With such a large transition on the horizon, there clearly is an opportunity for investors to find attractive opportunities that give potentially outsized returns. But be careful, because the volatility with the price of this metal is extreme. Today's video is brought to you by Lithium Chile. I chose Lithium Chile as a sponsor for this video because they have various potential brine projects with a property portfolio consisting of over 110,000 hectares in Chile and over 20,000 hectares in Argentina. The company trades on the TSX Venture under the symbol LITH. All right, everybody, thank you for watching. If you could do me a big favor, please smash that like button, subscribe, ring that notification bell. Also, let me know what you think of the lithium sector. Do you think it's still got legs? Are there stocks you like? Let us know in the comment section. All right, thanks, everybody.